files and parameters. So just a quick overview on what we're going to be covering in this workshop. We're going to first review some ROS fundamentals that we covered since the last workshop. Not as in-depth, but just a few key things that we need to understand, just some prerequisites in order for us to work with the rest of the material in the presentation. Then I'll be going over ROS launch files and parameters by themselves. And then I'll finally be going over how we use these in Sailbot Workspace. And there's a few demos that I also prepared ahead of time. So yeah, there's that. So you guys get to see launch files and parameters in action. So to start, there are essentially three core data structures in ROS that we need to know about for today's presentation. I'm fairly certain that all of you have seen these three data types in the last workshop. First is nodes. So nodes, I kind of stole this from the documentation a little bit, but it's a software entity responsible for a single modular purpose. And ROS nodes essentially are purpose for executing predefined tasks over and over again in a routine fashion. And these you might have multiple ROS nodes in a ROS network, and they each kind of execute their own tasks in isolation. However, these ROS nodes could also communicate with each other via publishing data to each other and subscribing, meaning they pull information from each other. And kind of how this publish and subscribing mechanism works is through something called ROS topics. So ROS topics, the documentation kind of calls them like a bus for containing data for node communication, but I kind of like to think about it as kind of like a mini database that stores info that has been updated by one of the nodes. Sorry, Jamie, you had a question?
No, it's fine. Sorry.
Yeah, no worries. Yeah, and then the way that these the way that ROS nodes communicate with each other are via ROS messages. So nodes may publish a message to update a topic, and ROS nodes may subscribe to a topic to receive ROS messages that contain updated data. So kind of like how this works in action is you have two ROS nodes here. One ROS node contains a publisher, so it constructs a message and it publishes data to a ROS topic. That message goes to the ROS topic, updates the topic, and then the second node on the left here shows a ROS node with a subscriber, and it's essentially pulling that topic, periodically pulling information from the ROS topic to receive data and then do whatever it wants with it in its routine. And ROS operates concurrently and iteratively. So what does that mean? Well, the iterative part kind of goes back to what I said about ROS nodes, how they operate. They operate in an iterative fashion. So they have some sort of predefined task that they know ahead of time that they're going to do, and you as a programmer define how often that this routine executes. So for example, I think in Sailbot Workspace, it's actually configured for 0.5 seconds. So all the ROS nodes will execute the routine every 0.5 seconds. And that's where the iterative part comes in. But where the concurrent part comes in, and I kind of include a definition here. So concurrent means operating or occurring at the same time. So all these ROS nodes are operating independently in parallel, and they're all executing their own routines in parallel, but then they also communicate with each other again via ROS topics and by sending messages to each other. So that's kind of a quick overview of ROS. Yes, the ROS fundamentals that we need in order for us to move on to ROS launch files. But before we get into ROS launch files, I think in the last workshop, when we talked about ROS nodes, we actually ran these ROS nodes using the ROS2 run command. And this works perfectly fine. You can definitely run ROS nodes one at a time using the ROS2 run command. So the example here that I kind of made was we have like a package called my package, and this package contains 3 nodes, N1, N2, N3. You can execute all 3 of these nodes in parallel by running these 3 commands in your terminal, and it will launch 3 separate processes for each ROS node, and they'll all run perfectly fine. And this is perfectly okay to start your ROS network. But with as big of a ROS network as we have, it's pretty tedious to launch. I don't know how many. I would imagine we have around 10 or more ROS nodes. Or is that a good approximation, you think? Around 10, I think, or maybe just under 10. I don't know, something like somewhere around that. So like imagine like you want to be like, oh, I want to start the whole ROS network, so I'm going to do ROS run, ROS run, ROS run. That's really annoying to do. And on top of that, ROS run actually launches a separate process for each node. So if you want to shut down the entire system, you have to kill each process that you launched manually, which is annoying to do. And if you forget to do that, then you're going to wonder why your computer crashes after a while, because you're going to have processes running that you forgot to kill. So that's kind of where launch files come in. So what is a launch file? A launch file describes the configuration of the system and then executes it as described. So what does this description mean? Well, there's quite a few things that you can describe when you're executing a launch file. But some of the descriptions that we use in Sailbot Workspace, and you'll probably see most often, is what nodes you are running. The launch file actually describes what nodes you're going to be running. So for example, I think Boat Simulator runs technically 2 nodes, the physics engine and the low-level control node. So we need to launch both of those in order for the simulator to work. So we use a launch file to actually launch 2 nodes. CLI arguments. So I think if any of you guys raise your hand if you guys have set the log level to debug before. And has anyone done that? The log? Yeah, so this is actually done using the CLI arguments, and ROS launch files essentially parse that, and it will do stuff with that, however you describe it in the launch file. You can define system variables, so again, like environment variables. If you've ever ran the logs before, you might have noticed that some of them are colorized. And one of the environment variables that you actually have to configure is you actually have to turn on the colorization. So that's an example of like a system variable that we configure to colorize the ROS logs. And then finally, you can actually define the default ROS parameters upon startup. We'll kind of touch a little more on ROS parameters later, but we actually use the launch file to essentially read in a predefined configuration file that actually reads in ROS parameters and then sets them to the correct nodes. And then there are various formats that a launch file can take, Python, XML, and YAML, but Python is particularly useful because you can do you have the power of the Python to do whatever you want with your launch file. You can do so much more than just XML and YAML can. And I think that's why we decided to go with Python. If you notice, all of our launch files are in Python, and that's one of the main reasons why we decided to go with Python. And kind of what I mentioned earlier is, remember how like we have to launch a separate process for each ROS node, right? Well, what the ROS launch file does is that it actually monitors all of the nodes in a single process. So when you execute a launch file, it runs all of the nodes at once, and if you stop the launch file, it will terminate all of them for you at once. And it will also take all the logs from all these nodes and display it in the same terminal. So that's one of the big advantages of using a launch file, is that it kind of manages that. Kind of manages the processes for each node for you, so you don't really have to worry about which processes do I need to kill, because you just kill one. And then launch files are also capable of coordinating each other. You can actually make launch files call other launch files, and I guess I'm spoiler alert here. This is what the global launch file does. We have a launch file defined in each of our packages, and we use the global launch file to essentially call upon each of these launch files and start the entire system. But again, I'll kind of go into more detail on that in a bit. And yeah, just as I mentioned earlier, it's pretty easy to run a launch file compared to just running your entire, each node one by one to start your entire network. Yeah, I'll move on here to ROS parameters. Just gonna pause though. Does anyone have any questions so far? Three, two, one. Okay, I'll take that as not right now. Okay, so this section is actually fairly short. I believe there's only one slide in this section on ROS parameters. It's fairly brief. But ROS parameters are essentially variables that are associated with a particular node. And the idea is these variables can either be statically or dynamically determined at runtime. And the advantage of doing this is you can actually change certain variables outside of the node's process. So you can actually enter your command line and change a ROS parameter, and it will update in real time, and your node will start using that new value that you set. Yeah, so all parameters must have a type, of course, and each node has to actually declare what parameters it's going to use ahead of time. I believe it will actually throw an exception if you try to use a parameter in your code that's not been declared. So, yeah, there's you have to declare those. Yeah, and then you can set ROS parameters using a predefined configuration file, which is what we do in Sailbot Workspace actually. You can set the parameters in code, and actually in my demo I actually do this. And then you can also change your ROS parameter in the command line interface, which I'll show you guys kind of how that's done in a bit. But so I guess the next section of the presentation is how ROS launch files and parameters are used in Sailbot Workspace. But before we kind of get into our code base in particular, I did kind of create a simple demo of a a simple demo where we have two nodes talking to each other. Let's get here. So what this demo consists of is essentially it has two ROS nodes. It's pretty simple. You have a talker and a listener. The talker publishes a string to a topic, and the listener listens on that topic, and it receives that data, and it's going to print out whatever it's just received from the talker. So I guess I can kind of start this process here. I think I'm actually going to split the terminal here. So actually, how do I minimize this? Oh, you know what? Oh no. Okay, no, I don't want you there. Oh my god. This bar is usually kind of annoying. Okay, wait. Oh, wonderful. Okay, it kind of went up. Perfect. Okay, so the talker, so this is it's called the publisher, but this is the talker. So all the talker does is we define a timer callback that executes iteratively, and every, I believe, 0.5 seconds, it's gonna publish a message called, we take a message string, and we take that message string and we publish it to the listener, and that message string that we have defined ahead of time is hello world, and it's defined as a ROS parameter. And then the listener here, also fairly simple. It just subscribes to that topic that the publisher is publishing to, and it just receives the data and prints it out to the terminal. So we can actually run these two nodes. So I'm actually going to use ROS to run here to actually start it. I think it goes ROS to run, I think it's package, yeah, and then node talker. So the talker is going to start, and it's going to start publishing hello world. ROS to run, because it's a pub sub listener. And then you'll see that it's essentially receiving the data that the talker is publishing, and it's echoing what it's publishing. So fairly simple here. But what I'm going to do is, notice how the message string here is actually defined as a ROS parameter. So remember, one of the advantages of ROS parameters is that you can actually change its value outside of the node's process, and it will update in real time. So I'm actually going to open a separate terminal here, and I'm going to set it to talker message. And I'm going to change it to goodbye world. So what this will do is it will actually contact the talker node, and it'll say, hey, change your message parameter to goodbye world instead of hello world. And I should set that. And if we go back to the terminal, we see that it's publishing goodbye world. So that's kind of a simple demo of how ROS parameters work. But you're going to notice that I actually ran two separate processes here for both the talker and the listener. So again, I have to kill both of these processes individually if I want to stop everything. So as previously mentioned, that's kind of annoying. So that's where launch files come to the rescue. And I actually created a launch file for this demo here. So what this launch file does, pretty simple. All it does is says, hey, I want you to launch both the talker and the listener in the same process. Pretty simple. And you can execute this launch file with the following command, ROS2 launch. ROS2 launch is what actually runs these launch files. You give it the package name if it's associated with the package, which it is, and then you give it the launch file name, which I called it main launch.py. And then you're going to see that it's actually going to run both of these nodes in the same process. And it's actually taking both of the outputs from both nodes and putting it into the same terminal. Pretty cool, huh? And then if we want to stop both nodes, we just kill this process, and that's it. That's simple. Any questions about this demo, though? Yes?
So ROS parameters are associated with a node?
Yes, they are.
Okay.
Yeah, so actually, I think this kind of circles back to like why you have to make a ROS node declare what parameters it's going to use. And the actual command that I used, it like ROS param set, you have to tell it what node you're going to set it, and then like what node you want to talk to, the message that you need, the parameter that you need to change, and then the actual value that you're going to assign to it.
I kind of thought nodes were with the ROS network fundamentals.
Sorry, I'm just going to close the door. Sorry, you said something?
Yeah, for some reason I thought parameters were just with the network in general. Can other nodes see the value of a parameter from one node?
Can other nodes say the parameter value from another node? I don't think so, because like, for example, even if you have a configuration file, the configuration file enforces that you actually associate a parameter with the node itself. So I don't know if you could like communicate ROS parameters between nodes. I haven't tried that before.
Okay.
Yeah. Anything else? Or I'll move on. Okay. And I'll go back to the presentation here. So where we left off was how do we use ROS launch files and parameters in Sailbot Workspace? So I'm going to start with launch files. So Sailbot Workspace makes use of two types of launch files. The first is a package-specific launch file, which only launches the node. And it only launches the nodes with a particular package. And then the global launch file, which actually goes to each package and it says, hey, I'm going to take your launch file and I'm going to launch all of you at the same time to essentially launch the entire network at once. And you can actually, both types support CLI arguments. So you can actually pass arguments into the launch files to configure different aspects of, I guess, how the system will execute. Do I go over this? I swear I had like a slide. Yeah, okay, I do talk about that after. So Next couple slides kind of talk about how the launch file architecture looks in Sailbot Workspace. And it is a bit dense at first glance, but there is a docs page on this. So if some of it is a little bit confusing, feel free to ask questions or refer to the docs website after the presentation is done. But the first we're going to go over is the package-specific launch file. So kind of where you start is, of course, when you're launching the launch file, you're going to launch it from the command line. And the command, within the command line, you can give your launch file command line arguments. So once you actually run the launch file, the next step it's going to do is going to actually, we kind of hacked this ourselves. This isn't actually something that's supported by ROS natively. We kind of had to do this ourselves, but we actually consult the global launch file and we say, okay, what arguments do you typically use so that we can use them? Because the idea behind the global launch file is that it will actually take arguments that are common to all nodes, sorry, not all nodes, all ROS launch files. But if we want to run the package-specific launch file by itself, we need to know what those global arguments are. So the next step is to actually go to the global launch file and say, okay, give me your arguments and give me your environment variables. So we're going to take the CLI arguments and those parameters, and then we're actually going to, in addition to the global arguments, we also parse the local arguments because some package-specific launch files will use their own arguments that are not available to other package-specific launch files. So once we get to step 3, we have all of our arguments and we have all of our environment variables, and then we actually filter the relevant arguments that we use because there are some global arguments that are not necessary, that are not relevant to some of the package launch files. And then we actually take all that information and then we pass it into the ROS node, and then we just start the execution of all the ROS nodes that are specified in that launch file. And how you run a package-specific launch file, there's a command there. It's ROS2 launch. You give it the package name, and then we follow the convention where we name all of our launch files main_launch.py. But you can, pretty sure you can name it whatever you want as long as it ends in _launch.py, because how the build process works in ROS is that it actually searches in order for it to know what files is a launch file. It uses a glob expression and it says, okay, if this ends in _launch.py, this is a launch file. So, fun fact. But that's for the package-specific launch file. But if we want to launch the entire system, we're going to use the global launch file. So the process is mostly the same this time around, except what we're going to do is, we pass in the CLI arguments, and well, we're already in the global launch file, so we already have access to the global arguments. And then we also read in the ROS parameter configuration file because that's, first of all, that's one of the parameters that's one of the parameters that we pass in. And second of all of the package-specific launch files need to know what parameters they're going to use. So once we have all that information, then we pass all that common information to each of the children launch files, and they all launch at the same time. And then we have our entire system launched. And the launch file command, the command for running the global launch file looks a little bit different than the package-specific launch file, because a package-specific launch file is associated with a package, but the global launch file is not. So you actually have to give it the full path to the launch file in order to actually run it, which is why it looks a little bit different here. That's it for the global launch file flow. And then finally, this is just about specifying CLI arguments. So if you want to say, for example, change the log level, an example of how you would do that is, well, typically when you actually pass in arguments to any launch file, the format that it goes argument name : equals value. A little weird, but it has to follow that specific syntax. Otherwise, it's not going to parse. That's just how it works. So for example, for those of you who said that, that you set the log level to debug before, you probably launched something like this before where you, say for example, you launch local pathfinding and you set the log level to debug, where the log level name, where the argument name is log_level, and then the value is debug. And if you're not sure what arguments a launch file accepts, you can always just run the launch file command and just append a flag at the end, -s. What that will do is it won't launch the system, but it'll just list the parameters that you're allowed to specify. But I think that's actually it for how launch files are used in Sailbot Workspace, theoretically. Does anyone have any questions on that? I know it was a bit much, but again, there's the doc site talks about this a little more in depth. And you can also play around with the launch files yourselves and look at the code. If not, then I'll move on here. I think there's a chat. Oh, never mind. Oh, that popped up. Oops, sorry. Sorry, Sean, I exposed you there. Okay. Oh, yeah. And then for ROS parameter configuration in Sailbot Workspace, as mentioned before, we use a parameter configuration file. And for everything to do with ROS parameters is contained within source global launch config, and there's two main files that you're going to worry about. The first is the readme.md, which describes all the parameters, their types, and how you can use them, and their acceptable values. And the second is the globals.yaml file, which is the file that actually contains the parameters. One thing to note is everything in globals.yaml, unless you specifically configure it inside the node for it to be read-only, these are all default values. You can actually, as previously demoed in the first demo, you can actually set these values in real time if you want to. So that option is there for you, but we also, this is just where all the defaults are defined, essentially. And then, yeah, if you want to add your own ROS parameters, which inevitably you will, because you're going to find that there are just some things that you want to configure, all you have to do is add the parameter to the definition, add the parameter definition to the configuration file, declare it in the ROS node, and then also, I didn't put this as a point here, but make sure you also document it in the README file so that others know how to use the parameter that you just added. Otherwise, if you see a mystery parameter in it, it has a hard-coded value of 5, it's like, oh, okay, that makes sense, right? Because you don't actually know, you might not know what it's used for, or you might not even know what the acceptable values are, because, if you don't tell someone that a ROS parameter only accepts non-negative values, and and if you don't tell them, someone can just put -1 and crash your node. So make sure you document it, please. Yeah, and then with that, I'll kind of go over quickly in Sailbot Workspace just what I just talked about with the launch files and the configuration file. So I think what we're looking for here is, yeah, here. So under the source directory, I'm gonna, dude, how do you minimize this? Oh yeah, here it is. So under the source directory here, you want to go to global launch in config, and this is where that readme that I was talking about is. There's some conventions at the top here that kind of describes how you should document your ROS parameters, and then you can just kind of add them here. So typically there's a description, what data type it is, and then the acceptable values, and that kind of just repeats throughout the file. I think if you take a look at what the file looks like on GitHub, you can kind of deduce what the pattern is. And then this is what the globals.yaml file looks like. So just a quick overview of kind of what this means. /** means that this could be used by any node. So I think that might circle back to James' question of can you communicate between ROS nodes? I guess you could do that with this /** because everyone shares the same publishing period. So you can associate a parameter with all nodes using this syntax here. So typically how it works is you start with the ROS node that you want to associate your parameters with, and then you put all your parameters underneath ROS __ parameters, and then you list all your parameters below. So for example, this is local pathfinding here. So local pathfinding looks like they have a ngp _ main node, and they have these ROS parameters associated with them. And these parameters are only associated with that node. They cannot be shared with other nodes. And as mentioned before, all these values that are specified here are default values. So these are values that are read in on startup. And yeah, I think that's it that's mostly it for the ROS parameters at this point. Are there any questions? Okay. So for the global, I'll start with the global launch file because that's kind of where it's most natural to start. So most of the ROS launch files kind of follow a similar structure. You have all these import statements, but you'll also see where the actual CLI arguments are defined here. So in the global launch file, we actually declare 3 different arguments. The first one is the path to the configuration file for the ROS parameters. The second is the log level. And the third is the mode, whether we want to run in production mode or development mode. And if we actually run I think it was like ROS to launch, I think it's source, source global main launch.py, ROS to launch, and if I add that -s flag, remember -s should actually list all the parameters that this launch file will accept. It should print exactly what's here. And you'll see that like ROS even kindly tells you how to pass in the arguments. It has name : equals value, and then has the 3 different arguments here. So if you wanted to add another argument, like if you think there is an argument that is relevant to all ROS nodes, you can add it to this list here, and the launch file will take care of the rest. It will parse all these arguments, and it will and then you can use them however you want inside the launch file. Here are some environment variables that we define. One of them is the ROS log directory. The other is saying that we want to colorize the log output. And then here is where the launching actually happens. So when you create a launch file, it's the documentation. They call them launch description entities, which is really abstract and is a little confusing. And to be quite honest, I don't think I can fully explain what a launch entity is, but in our use case, it's essentially any arguments or nodes that you want to launch. That's kind of how I can describe it in our use case. So in the global launch file, we actually pass in the global launch arguments, and then we call this opaque function here. And all this does is it will call the setup launch file, and it will basically, this will return more launch description entities. And what are the launch description entities in this case? Remember that the global launch file actually calls other package-specific launch files. So in this case, the entities that we're actually adding to this list up here are the references to the package-specific launch files that we're going to launch. That's how that works. So there's actually, if you actually look at the code in this launch file, there's actually no nodes that are directly being launched in this file, because all it's doing is it's iterating through all the possible package-specific launch files that it wants to launch, and it just says, I want to launch your nodes, I want to launch your nodes, you get to launch, everyone gets to launch, I don't know. I'm sorry, I'm not funny. I'm sorry.
I like that.
I don't know. And this is recorded too. Oh well. But yeah, more or less, this is what the global launch file is doing. It's just defining any global arguments, and it's just grabbing the references to the package-specific launch files. And most of the interesting stuff actually happens in the package-specific launch files. So I'll kind of go over one example. I'm going to go over the boat simulator because that's the one I know the best, but I think most of the other launch files follow a very similar format. Let's see. Go here. Yeah, we'll go here. Launch file. Main launch file. Okay. So, in addition to global arguments, the boat simulator also uses its own local arguments. So, I won't go into details of what they do, but essentially, if we actually ROS to launch boat simulator launch.py-s. So if we list the arguments that the boat simulator is going to accept, it is actually going to give you a slightly misleading output, and I'll kind of explain why. So, oh wait. No, this is not misleading. This is actually, it never used to do this. You know what it used to do? It actually used to just print the bottom two. Okay, never mind. I just, this is new, cool. Looks like it actually lists the global arguments as well, which is actually what we want. Perfect. So it's gonna list all your global arguments and your local arguments as well. I'm actually very happy about that. That was actually a really annoying bug. As you can kind of tell, I kind of impromptu here, but so it goes. And then the boat simulator is going to generate its own launch description. So it's going to grab, okay, so before I kind of go into the launch description, I'm going to talk about that hacky part that I mentioned earlier. If we kind of go back to the slides, what the package-specific launch file will do, if you run it by itself, it will actually, it has to consult what's inside of the global launch file in order for it to use the global launch file arguments. So how that's done in code is, I believe we wrote this, yeah, we wrote this function called get global launch arguments, and it uses a Python library to essentially run through the global launch file without actually running it to grab all the variables. And then it will grab the global launch arguments and global environment variables specifically and return those. So in here, we actually grab, those are the first things that we grab. We grab the global arguments and the global environment variables, and then we add those to the launch description entities that we want to launch with. And in addition to the global arguments, we also add our local arguments, of course. And then finally, we have an opaque function which does a lot of the interesting stuff, but to essentially sum up what this setup launch function does, it just grabs all of the nodes that it wants to launch, and then it just returns a list of nodes. So if we go back up here, you have your arguments, your environment variables, your local arguments, and all the nodes you want to launch. And that's how the package-specific launch file works. And then, yeah, there is a bunch of code at the bottom here that kind of essentially, this is where the CLI arguments are actually read in and passed into the node. So for example, this is where we actually, for example, parse the log level, and we actually use that to set the log level. But you can kind of take a look at what your launch file does for your project, because I'm sure that it parses some sort of argument. And you can kind of see how you can actually read in CLI arguments and use that to configure how you actually run your ROS nodes. And I guess I'm sure all of you have done this before, but I'll do it anyways. I'll just run the whole system. Actually, no, first I'll just run the boat simulator just by itself. And if we go to ROS to, I guess, node list, right? You'll just see that just the two nodes associated with the boat simulator are running. Excuse me. And this is just with the boat simulator running just by itself, running using its package-specific launch file. So if we kill this, and if we check back up on what nodes are there, it's going to kill all the nodes associated with that launch file. But if we actually run the global launch file, again, what it's going to do is it's going to go to all of the package-specific launch files in the workspace and launch all of them at once. So this will actually launch every single node in our system. And if we take a look at the node list, you'll see all of our nodes in the node list. Yeah, I guess. I don't know, I didn't count. I don't know, maybe it crashed, I don't know.
Oh, yeah, it did crash.
Yeah, it did crash. Yeah, oh no, Path hasn't crashed.
Yeah, I think I understood.
Oh, well, it's okay. And anyways, I'll just I'll stop the global launch file, and then I'll list the nodes, and then they're all gone. So again, this kind of circles back to how a single launch file can control 8 different nodes, and just killing the launch file will just stop all the nodes at once. So you don't have to manage 8 nodes at once, right? It's kind of a crazy thing to do. And then yeah, I added some resources here, kind of what I consulted to create this presentation, but what also will be helpful for you to read up upon if you want to learn more about. We'll learn more about launch files and ROS parameters. There's a lot more about these 2 topics that I didn't mention today because you could do a lot more complex things with these 2 things. But today I mostly touched upon about how we use them. But of course, if you want to take more advantage of their features, and if there's a use case for them in the future, then I strongly suggest that you read up upon launch files and ROS parameters in the ROS 2 documentation. And that's it.
Where can we find your slides?
I'll send a link in,
Okay.
but it's in Google Drive. I'll send a link in Soft General. Any questions? I'll check also Zoom just to make sure.